Hey guys, David here and welcome to another part of the RatRig KillerBee CNC build series. Today, as you can see, quite a bit of this has changed, but I'm actually not going to talk about the closure at all, since it is not complete yet, but instead I'm going to talk about this box, or more what you cannot see because it's on the other side. But before I get into the weeds of the electronics, I just want to quickly show all the things that the machine can do now. At this point I also want to give a big thanks to PCBWay for sponsoring this video. They make super high quality PCBs at a very affordable price and have their 4th PCB design contest going on. You can design your own PCB, submit it there and win one of many amazing prizes. So no matter your experience level in PCB design, if you're interested at all, make sure to go check out PCBWay.com to find out more. First of all, let's hold the machine. And then let's move around a bit. Pretty cool, isn't it? This is running at 10,000 millimeters a minute rapids, so quite a bit. Right now at 1,000 millimeters per second squared accelerations, but I might increase that slightly. I'll have to see. I have not played around with that too much, but the closed loop stepper drivers really shine here, being able to deliver those high rapids. With 10,000 millimeters a minute, the stepper motors themselves are turning at 2,000 RPM, which is quite fast for a stepper motor, but for these ones that should be perfectly fine. I can also, instead of controlling through the keyboard, I have hooked up this MPG. So for like dialing in a workpiece exactly, this is great. This is what's right now the coarse setting. You probably won't be able to see it, but I can make super minuscule adjustments. Maybe you can make out the motor shaft turning ever so slightly. This is going to be great for like finding 0 points, making sure that the clearances are right, anything like that. I have also hooked up this little probe here, and this is just a tool setter. I've not calibrated it or used it, but that also goes ahead and registers inside. And of course, most important of all, the first step was this e-stop. So if it's doing anything, you can just smash that e-stop and then it goes into emergency stop and I can just simply reset it. This was super helpful, like when setting up the homing and everything like that. Oh no, it's moving in the wrong direction, it's gonna crash. Smash that e-stop. Now this will not live up here with these wires dangling, of course. As you will be able to see in a second, on this side the door is still missing, so I'll have a door there where I have the on-off switch and these like emergency stop and everything like that, since here of course will also be a window in the end, so you won't be able to smash the button here. The other thing that I haven't shown yet is the spindle, which I'm not sure how well it's going to be visible, but you'll definitely hear it. So yes, the spindle can of course also be controlled through Mach3. So here we are now on the main side of the electronics cabinet, and as you can hear, the VFD is quite loud, so I'm actually going to go ahead and turn it off for now. Right now we just have this very precarious switch here, because it's not mounted yet, which is definitely far from ideal, but this will later live in a door somewhere around here and be quite convenient. So I'm gonna kind of split this in two parts. First, I'm gonna just give you a very brief overview over everything to see like what I'm using, what components, since I think that's gonna be most interesting for a lot of people. And after that, I will go into the very details of configuring like which component to wire up how, because I had quite some troubles, and I'll go into that in a second. At the heart of everything, the controller I'm using is an NVEM V2 from Novusun. This is kind of like mid-range Mach3 controller off of AliExpress. It's not the like super cheap parallel port kind of deal, but it's also nothing fancy. The controller itself is quite decent, but the manual for it is horrific. In some areas it is missing very crucial details, while in other areas the details that are mentioned are just plain wrong. But I will go more into detail on that later. Then connected to that, we have the 4 motor drivers for the closed loop stepper motors. They are also very generic from China. The model number is HBS 57H. They do not have any brand name on them, but they work quite well as long as you hook up everything correctly. As once again, there is not really any manual, and hooking up all the encoder signals correctly is very important, otherwise they just don't work. They are labeled on the motors, which color does what, but just in Chinese. So either you'll have to translate that, or I will show you later what I found out through watching somebody else's video. Then for the spindle itself, here is the VFD for it. It's a Huanyong VFD, so also like not the very cheapest knockoff, but also nothing fancy once again. It does its job and is controlling a 2.2 kilowatt air-cooled spindle. To power everything for the stepper motors, we have this 60 volt power supply here that gives juice to them, and up here a 24 volt for all the logic. On the input here, just a simple fuse, some distribution blocks, and here I have 2 relays as well, where I will be able to hook up like any sort of coolant or anything like that. I've not hooked anything up to them yet, but well, I'll definitely have some sort of dust collection, and I will be able to trigger that through that. And then connected through this Ethernet cable here is just an old laptop. It's actually the same tablet that I'm using to control my other CNC. I might get a second controller at some point, but for now this does the job, and on there is running Mach3. I think the way I'm going to do it is that at the very end of the video I will quickly go over to Mach3 and show you everything there. So I'll of course have timestamps down below if you want to jump to that. Alright, so story time. The reason why it took this long for this video to come out, it was supposed to come out like right the week after the previous CNC video, and I had most of the electronics assembled and everything. But getting this stuff to work ended up being a challenge on every single step. First challenge was getting the controller to talk to the computer. In the manual for the controller, they tell you to either connect it through a router, which is the preferred method according to them, or connect it up directly to a computer, just into the Ethernet port. Now, I don't know what kind of magic they are using, but definitely connecting it directly should be much the preferred method, as there is no chance for any packets to get lost or anything like that on the way. And then they give you the IP configuration options that you need to put in. However, the IP address that they list is just straight up wrong. If you type in that IP address, it will not work. Instead, you put in these values here that I found through some really great guys on YouTube. I'll try to link everything down below. I'm not sure if I can quite remember all the videos, but everything that I remember will be linked down below. And thanks to those guys, I was able to figure out the right IP address and get it configured. Then the first step was to hook up the e-stop switch and to make sure everything is working there. Now, it did come with a Mach3 install, which was largely pre-configured, which is quite great. You don't like all the ports and pins are already correctly in there, and it is also activated. At least in some fashion, like you don't need to buy a Mach3 license. How legit this license is, I don't know, but it came with it, so I'm gonna roll with it. Then the next step for me was to hook up all the motor drivers. It is relatively straightforward to hook them up. On the bottom you have for your XYZ axis and ABC, you just have a common positive, and then you have the step and the direction negative pole. On your motor driver, you'll have positive and negative for pulse and direction, and you just hook up the positives together with this little loop-de-loop, and then hook the other ones up directly to your controller. If, like me, you have two drivers for the y-axis, then you will just hook up one of them to the a-axis, and later inside of Mach3 you can connect these two axes together and have them act as one axis logically. What was quite challenging for me is hooking up all the different connections for the encoders and the motors correctly. The motors are fairly simple. You can just figure out which coils are connected, and then it doesn't really matter. But for the encoder, if you have any of these two switched, it's gonna just make really weird noises and jump a bunch around. So if you have the same ones and hook it up exactly like this, it should work. But one other thing you need to be careful of is that you connect the right encoder to the right motor driver. It's kind of almost embarrassing, but I'm sure I was standing here trying to figure out why it was not working for at least like 2-3 hours, until I noticed that I had the Z encoder hooked up to the X motor and the X encoder to the Z motor, which it of course caused them to not get the encoder signal back that they're expecting, and then go into emergency shutdown. After that, it was fairly straightforward, and I got all of them hooked up. You'll also want to configure the dip switches up here for the kind of micro stepping that you want to use. I'm going with 3200 steps per revolution for right now. That's just kind of a good baseline. Might try out if I can go one higher without losing any rapid speed, just to have a bit more resolution, but this should be fine. Then the other dip switches you just set according to which motors you have, and it is actually labeled on the drives themselves here. You could also hook up these drives through this other connection protocol, but I have no idea how that actually works, and there's not really any need. If you want to change any of the settings, you will need to hook up through that, but out of the box, for this application, they work fine. Then the next challenge was the VFD itself, and once again, the manual for the controller did not specify a lot for the VFD, just kind of said, yeah, hook this stuff up. But it's not really its job necessarily. The manual for the Huanyang VFD is actually really good. It is super detailed, but it is also super technical and actually quite difficult to understand and has a lot of pages. So finding which settings you actually need to change in there is quite difficult. So out of the box, there's actually not a lot you need to change. If you want to control it through the controller instead of the buttons on here, one thing you need to do is, of course, hook it up. As you can see here, you need to hook up the forwards, the reverse, and the voltage in, which is for the speed. And then there is a common ground, which is DCM, but also ACM. So you need to connect to both DCM and ACM. And one thing you also should not forget is to change the little jumper here. Nothing mentioned that to me until I watched a Spanish YouTube video that told me. And after changing that jumper around, you should be able to control it through Mach3. And then the last big mystery was this MPG. It came bundled together with a controller. So I was like, yes, I'm gonna have an MPG. I don't even have an MPG on my big mill. And it is really convenient now that I have it hooked up. It has about 24 wires that are unterminated, and the manual for the controller has the spots of the color for the signals just left blank. And I could not find any other manual. I found manuals for other MPGs. Tried hooking up like that, did not work whatsoever. What ended up working for me in the end was removing 6 screws from the back, opening it up, and inside where the wires were soldered, these terminals were actually labeled. So I was able to use these to figure out what connects to where. And on the control itself, it is actually labeled. If you happen to buy the exact same one, I'm gonna post a picture here of the connections, so you can save yourself some trouble. Otherwise, just opening it up, the 6 screws in the end, it's very easy. Just in case it does not work, maybe they hooked it up differently or something. not sure how standardized that is. I also, of course, have the limit switches hooked up here. The ones that come with a KillerBee, they need just positive, negative voltage, and then they have a signal out. So you connect the positive, negative to the controller, and then the signal is the input pin. And that just works great basically out of the box. When they are not pressed, they have a dim red light glowing on the switch, and when they are pressed, there's a brighter red light. That's how you know that they're receiving power and are actually sending the right signals. The probe and e-stop are just simply hooked up directly to the corresponding pins. In that aspect, this controller board is really nice, as for the basic things that you would want, it already has everything pre-configured, and there's no really big need for setup. Alright, so we are inside of Mach 3 here, and as you can see, it might look slightly different than what you would expect from Mach 3, and that's because I'm actually using the Physics Anonymous, which is another great YouTube channel, screen set that they created for Mach 3, as, well, the default interface is very dated and kind of clunky to use and quite horrible for touchscreens. This one is optimized for touchscreen and looks a lot better. I still have some scaling issues as I'm using different screen resolution, but I'm sure I can get that sorted out as well. For the most part, this is going to be very similar as if you're using the standard screen set, and most of us what we are going to do is in the configurations anyhow, where this does not apply. So let's start off with ports and pins, as this is where the main configuration is, and all of this is basically already configured if you're using the Mach 3 install that came on the CD drive of the controller. One kind of curious thing is that you actually do not want to put in any step and direction pins here. You want to leave that all 0 and just enable the axes that you are actually using. Then for input signals, it's basically the same. I did go around and change that slightly since I hooked it up a bit differently. Your inputs are all on port 1, and then it just starts with, I believe 1 would be the e-stop. Yeah, 1 is the e-stop, 2 is the probe, and after that it just continues on with the regular inputs. I have my XYZ end stops hooked up to input 8, 9 and 10. I have them configured as home switches, as I only have them on one side and I want to use them for homing. You could also have them as X positive, Y negative or stuff like that configured, but I'm not using that at the moment, so I just have them as homing switches. For output signals, there's not really anything you need to change in here if you're just using the default things. And then encoders, MPG, if you're using the MPG, you need to just put in the tick mark in here. For MPG1, once again, no need to put in any ports or pins or anything like that. Spindle setup, these are the settings that are working for me. I'm not sure if they're quite correct, but there was not that much change from the default options. One other thing you need to make sure is that in configuration, configure plugins. If you're using the MPG, here's your Novosun plugin for the controller. In config, you want to use standard MPG if you have like the standard one with a bunch of wires, or NVEM if you have their proprietary, like fancier one. Then of course you also need to set up the motors properly. Just need to set up the steps per unit. I'm of course using metric, so 400 steps means 400 steps per millimeters. That is with the 3200 steps per revolution that I have set my motors to, and the 8mm pitch of the least screws that the KillerBee is using on all the axes. Now I might go in later and do a calibration, measure if that is exactly accurate, otherwise you can change that here. But theoretically, since the lead screw has, I'm assuming, perfect pitch, and the motors are also controlled, it should actually be exactly like that. Then velocity here, if you're not using closed loop stepper drivers, 10,000 is definitely too much. You don't want to probably go over 5,000, but with this setup, 10,000 millimeters per minute should work fine. Here is where you set the acceleration. I have it set to 1,000 for now, which works fine. This stuff right here you can mostly just leave blank, and then after you did the changes, make sure to hit Save Axis Settings that will apply it. Then you need to do that for all the axes. On the Z-axis I have it set quite a bit slower, only 2000 millimeters a minute. That's just because there's not a lot of Z travel. So there's not really any point in having it go too fast. I'm just going to ram it into stuff. Then if you want to use the homing, you set that up in here. The only things that you will want to change is for the Y and the Z axis, I am actually homing negative. So I want to put the tick here. That just means that you don't go to the 0 position. So 0 Y will be in the front of the table, but I want to home at the back. And the Z axis is homing up. So it's both of these are homing negative. And then just for my units, I put in for the Y-axis that at the homing position, which is all the way back, it is at 785 millimeters, which makes the very front of the table exactly at 0. That just is a bit easier for me to work with to have that in positive values. For the Z-axis, I have the 0 set at the very top, and I'm just working with negative values. It does not really matter, it's just kind of a preference thing. With that, I have an effective travel of 785 millimeters on the Y-axis, and 540 millimeters on the X-axis. The Z-axis depends a bit on your table material. Right now I have around 93 millimeters, but after I surface it, I'll probably have around 95 or something like that. But it's not a lot, and it could definitely go down lower. So if I ever need more Z travel, I can remove the table material and clamp my workpiece a different way, and then I can probably get around 100 or 110 millimeters. To make sure that both of your Y-axis motors are actually working together, you go to Configuration, Slave Axis, and here for the Y-axis you want to select the extra axis that you have it connected to. So for me it will be the A-axis. After applying this, restart Mach3 and then the motors will always work together. Now, due to the way that they work together, before you kind of start cutting, you will have to make sure that the X-axis is perpendicular to the Y-axis, and then kind of manually turn the motors, and after it's turned on, they keep their position and they always stay synchronized. Another option would be to add a second limit switch and home them separately and just tweak those limit switches to have it perfectly perpendicular. That's definitely the better long-term situation, but the machine came with just one, and I think that is perfectly fine as well. It's also easier to set up. Inside of spindle pulleys, if you have your spindle set up, then here you also want to put in your maximum and your minimum speed for the spindle. That is just so that everything is displayed correctly, and if you send G-code to it at 24,000 RPM, that it then sends the maximum voltage. And that, I believe, is mostly it. One quick tip would be that diagnostics panel is really useful for making sure that everything is hooked up correctly. It looks a bit different on the default view, but it has basically the same information. Here you can see all the different inputs. So if the machine was actually turned on and I hit one of the limit switches or the E-stop or the probe pin or anything like that, one of the lights here should light up, and that way you know that it is connected properly before you start ramming into stuff. So I hope this video helped you guys out if you are either considering the RatRig and want to go also with a bit of a fancier CNC controller instead of the kind of black box that they offer, or if you're building a different kind of machine and want to know how to hook this stuff up. I'm sure this should definitely help out a bit. So if you liked this video, leave a like down below. If you have any more questions, suggestions, anything like that, the comment section is also down there. If you want to buy any of the products featured here, I will have affiliate links down below in the description as well. So if you use those when building your CNC, that would be greatly appreciated. It doesn't cost you any more, but it really helps me out a lot. So with that said, thanks for watching, and until next time.